Hi and good morning. Welcome to my video number 3 on mth3500. Now I would like to explain a little bit more on how to construct the flowchart. Okay. Yesterday one of you asked me how to n factorial, how to do n factorial, and she doesn't understand that. So for n factorial, how to evaluate this, or how to construct the flowchart for n factorial. So what is n factorial? You know that n factorial is defined as 1 times 2 times 3 times 4 and so on to n. Okay, so given any n, our procedure should ever to evaluate whatever n factorial, whatever given n factorial. Now how do we do this? Of course, when we want to evaluate this, we should give a name to the multiplication of this. All right, we give a name. So let's call this name what? Factorial stand for f. F stand for factorial. So let's say we give a name n. And if you look at this, we have 1, 2, 3, 4. We need a counter. Okay, we need a counter. That's the first thing. We need a variable. What do we need? We need a variable. What do we need? Okay, we need a variable. What variables? N factorial itself. Okay, whatever value n that we want, n, that's n factorial. What else? You need to multiply all this thing and give it to name. Here we call it f. That. Okay, and you also need a counter. This 1, 2, 3, 4, 5, 6, 7, 8 and so on. So we need a counter. So let's just call those counter m. Okay, first thing what we need to do, of course we begin with start. Okay, what do we need to do? We need to read in. You have to give the value for n, so we need to read n. Okay, input n. You need to input. We need the input n. You input the value. You give any number of n. Okay. Next, we need to give an initial value. Initial value. What is the initial value? Here, this is the multiplication. For the multiplication, the initial value for f, we give 1. Okay, why 1? Because you start multiplication with 1. If you start multiplication with 0, everything will come 0. That's not correct. Okay, if you start with 1, then 1 times 1 is 1, 1 times 2, 2, 1 times 3, 3, and so on. So that's why we begin with, for multiplication, we begin with 1. Right? That's the initial value. For the addition, that's we have seen in the example that I gave earlier, where the initial value we give 0. If you remember that, I put summation is 0. Because this is a kind of identity for the addition in the real numbers, as well as this is the identity for the multiplication in the real numbers. Okay, so what else do we need? Then we need to multiply those things. Okay, 1 times 2, you got 2. Then you give the value to f, and then you need to multiply 2 times 3. Then whatever the result, you need to multiply by 4. Whatever the result, multiply by 5 and 6 and so on. So do it step by step, one at a single step. Okay. So next step is 1, 2, 3, 4. We need, okay, and then we need a counter m as well. Initial value m equal to 1. So our f is equal to f times m. Okay, this is old value, this is old value. So which means old value in this case, f is 1, m is 1. So m times 1 times 1 is 1. So we have those things. Okay, next, if we increase m to 2, so we have the new value for m now is 2. 1 times 2 is 2. Next, we increase by 3. F now value is 2 times 3, you got 6. Now the value for f is 6. 6. Next value for m is 4 times 4, 64, and so on and so forth. So which means we need to increase m. How to increase m, and how much we have to increase. Okay, so we need, in this case, m is equal to m plus 1. Okay, that considered as a counter. So if you can see here, then we need to do a test. Now, yeah, you need to do a test. What test? That m cannot be greater than m, because we want to find n factorial. Okay, we need to find n factorial. So then if m is greater than n, then we print the outputs. Then we print f. So this is 1, 2, 3, 4, 5, 6, and 7. If not, if m less than n, okay, we repeat the loop. Go to step 4. Okay, then that's our process. N. Now, this is the process that we need to go through to evaluate the n factorial. Now, how to develop the flowchart? So with flowchart, we begin with start. Okay, then we need to input n. This is for the input n, and then we need to give the value for f and m. Give the value, initial value, f equal to 1, m equal to 1. Then we need to do that process. Okay, that process. F is equal to f times m. And then next, we need to start counting for m. m plus 1. Then we need to do checking there. Okay, if m greater than n, okay, if yes, we print. I put it here, I don't have space. Let's continue up there. Let's call this A. Here, I continue here. This is A. Then we print F as an output. Then we end the process. And here, if this is yes, it means we have achieved our target. So if not, we have to, I think here we need m equal to n, not that. M equal to n. Okay. If not, then we keep doing the multiplication. Okay. So that's the process for the construct the flowchart for the n factorial. Okay, if you read this, if you want to read this, we input n, and then we give the initial value, and then we do the multiplication process to find the factorial, and then we increase the counter. All right, here we do test if m equal to n. If not, now m, look at this, how to read this. M equal to 1. We do all this thing with the value n equal to 1 here. Then we increase m 2 here. Alright, now m equal to 2. 2 equal to n? No. 2 equal to n. And our n is, let's say you put n, let's say you put n5. Okay, we input the value n5. So 2 equal to 5? No. If not, then it goes up here. Do multiplication, 2 times m. F is 1, 1 times m is 2, so 1 times 2. Then we increase m. Now m is 3. 3 equal to 5? No. Okay. Then we're going up. What is f? Okay, put this way. F and m. Okay. Initial value m is 1, and I put n. You put n is 5. Initial value f is 1, m is 1. Okay. We come here, m times m. So the second step, 1 times 1 is 1. Then we go next. Step m plus 1. 1 plus 1, you got 2. Here, 1 plus 1, we got 2. We do the check. Is 2 equal to 5? No. Go up, do that process again. Now this f is old value, which is 1. M is the old value, which is 2. So f 1 times 2, you got 2. So we have 2 here. Right? Then we go next step. M, we increase 1. 2 plus 1 is equal to 3. Check. 3 equal to 5? No. Going up. Do the process again. 2 times 3, you got 6. Then increase m, you got 4. Check. 4 is equal to 5? No. Then going up. 6 times 4 is 24. Okay. And then increase that. You got 5. 5 equal to yes. Yes, it going out. Only 4 factorial. We need 5 factorial. So it should be greater than. Sorry about that. Greater than. Okay. So m greater than n. So 5 greater than 5? No, it's going up. Do the process. 24 times 5 is 30. 24 times 5 is what? 120. Yeah. 120. Then increase that 6. Check. 6 is greater than 5? Yes. Okay. Then go out. Print f. So print f, the final value f is 120. That. Then n. So 120 is the value for 5 factorial. Okay, so this is for the n factorial. That's all for this example. Now I want to proceed a little bit more on how to develop a C program, the very basic C program. What to do, what do we need to have. Okay, now since this is very introductory, I just want to give you what do we need to have in a program. Okay, because the major concern in this program, in this course, that at the end of the semester you should be able to do the program. Okay, let me give you just a very brief introduction, and then detail of how to open up the file, how to write a very simple program that I will give in Google Meet. Okay, now for the program, C program, the general skeleton, the general what we call that structure of the program. We need a kind of head. Okay, we need a body, and we need a tail. Must follow that order. What is head, what is body, what is tail? Now in the program we need what we call as a pre-processor directive. Yeah, processor. Yeah, preprocessor. We need a global statement or global variable, global declaration. Then followed by main. This is a must. Main. Okay, we open the bracket, we close the bracket. So what inside here? Inside here, this thing. Okay, so what is head? Head normally give as a declaration statement. We call it as a declaration statement. I explain to you what is declaration statement. Declaration statement. Then we need a body. Body, this is the process that we need to do to solve the problem. Okay, for example, in the case of finding this n factorial, the process here is the input n is the process, give you the initial value is the process, this multiplication is also process, adding the counter is the process, printing is the process. Okay, we need all those things. So what is the variable? What the variable name is n, f, and m. That's we call it the variable because those values varies. Okay, so if you consider the factorial n factorial as an example, so the variable statement is we have n, we have m, we have f. So the process is everything that I mentioned earlier, and the tail here, tail is we print out the result. Print out the result. Or output. Print output. So basically this is the general structure of C program. Okay, this is the general structure in C program. So what we must have here is that main, you must have this, then you need to open the bracket, you need to close the bracket. This is a must. And also the pre-processor statement. Pre-processor statement is that in order for you to, for example, I give you, for example, if you want to to read the data. So to read the data, that in C we use scanf. Okay, those scanf, example scanf, this is a standard input that C provided, that's compiler C provided. So this we call it pre-processor. To print in C we call it as a printf. Okay, printf is the standard output for C. So in order to use this standard input output in C, we need to to give the predecessor. To how to write the predecessor for the input output is, we have this symbol, that symbol, include without space, include, and we need this bracket, and inside there is a standard std io.h. This means standard input output, and this, the extension h, is to show that this is the link with the existing or the already built function, which is scanf and printf. If you want to use some mathematical process, like example, plus, minus, or multiplication or division or whatever it is, so we need to include here is math.h. Okay, so this is all the necessary part in order to construct, to develop a program, C program. Okay, for the detailed example on how to open the file, how to write a very simple C program, I will explain in Google Meets. Okay, I do a live explanation for that. So for now, I think I gave you another example for how to develop a flowchart. In this particular example, I explained n factorial here, yeah, how to set up n. So I explained that step by step, yeah, that those processes step by step process until we finish the n factorial. So you can think how to, based on that flowchart that we have, maybe you can write what is the pseudocode of that program. Okay, you do this as an exercise for you. Write the pseudocode. Write the pseudocode for n factorial. Okay, and before I end up this video, I would like to you to think how to evaluate, example, how to evaluate this 1 times 3 times 5 times odd numbers, 7, and so on, up to some number here. You choose that number. Alright, I purposely don't want to give what is the ending there, but you choose that number. That's one, and another one is we do this summation. Same with whatever number you want. Of course, odd number here. Okay, try to develop the flowchart for these two problems as well as pseudocode. Write down the pseudocodes. Okay, so with that I end up this video, and we'll meet at the Google Meet. Okay, bye bye.